Okay, this is part of the differentiation topic. We're going to have a look at the derivatives of a number of trig functions. They're not a particular example number. We'll probably fit it in example 10b because it goes in between example 10 and 11. We need this stuff to do the further example. So a wee quick demonstration of 4 standard derivatives. I'll try and be as quick as I can, and you can pause the video and if you're not sure and go back and do it again. So we're going to have a look at 4 different functions: tan x, sec x, cosec x, and cot x. We're going to prove the derivatives of each one here. So first of all, tan x. So if f of x is tan x, we can think of tan x as actually sin x over cos x. That's knowledge that you should have. If not, then now you know. We can represent tan x as sin x over cos x, which we can then use the quotient rule to work out. So the derivative using the little quotient rule formula looks like that. So if we define u as sin x and v as cos x, then u dash will be cos x and v dash will be negative sin x. So if we substitute these in to the quotient rule, u dash v will be cos x times cos x, and we're just quickly going to write that as cos squared x minus u multiplied by v dash sin x times negative sin x is negative sin squared x. Okay, negative sin squared x. I'll write it in. Okay, I could jump ahead, but I shan't. And then v squared, isn't it, in the formula? Well spotted. Will be cos squared x. Now, there is one line of simplification that we can quickly do, which is to make that plus there. Okay. There's one other piece of trig identity that we can spot: cos x plus sin squared x. This arrangement here always has the value 1. That's one of the kind of standard trig identities that hopefully you've come across before, and we're going to use it and we're going to claim it in this case here. We can simplify that to 1 over cos squared x. So the derivative of tan x is 1 over cos squared x, but we now have a new function which represents 1 over cos x, and that is sec x. Sec x is 1 over cos x. So 1 over cos squared x we can just write as sec squared x. In other words, the derivative of tan x is sec squared x. Okay, that's the first one. Second one, we have sec x itself. What's the derivative of that? Well, in order to be able to differentiate it, we have to write it down as the other form, 1 over cos x. There's 2 ways we can do that. We can either use the quotient rule, or we can rewrite it just as cos x to the power negative 1 and use the chain rule to differentiate. So the derivative of that would be differentiate the outside function and reduce the power by 1, multiplied by the derivative of the term inside the bracket. Cos x differentiates to negative sin x. So we've got 2 terms multiplying. We've got 2 negative terms, so that becomes positive. So overall, we have the sin x term on the numerator, and this cos x to the power negative 2 means it's on the bottom of the fraction, and it's a squared term, so we're left with sin x over cos squared x. So we can't really go far with that as it is, but what we can do is recognize that cos squared x is cos x multiplied by cos x, so we can actually split that up into 2 separate fractions that are multiplying. On one we can write down the numerator sin x, which means on the other one we would have to write down 1. So we have decomposed one fraction term there into 2, And the reason why we do that is that sine x over cos x we know is tan x, and 1 over cos x we've already defined as sec x. In other words, we have just shown that the derivative of sec x is tan x sec x, or sec x tan x. It doesn't matter which way around you write them. Okay, moving on. The next one is quite similar in starting point. We're going to find the derivative of cosec x, which is not 1 over cosec, but this time it's 1 over sine x, which means that we can represent it as sine x to the power -1, which means that the derivative will be negative sine x to the power -2 multiplied by the derivative of the term in the bracket, which is cos x. It's very similar to the way we did the last one. Overall, the result will be negative this time. We've got cos x in the numerator, and this time it's sine square x, which is on the denominator. And what we can do there is we can, again, split the fraction into 2, as we did in the last one. We can write down cos x over sine x multiplied by 1 over sine x. Now, cos x over sine x is it's tan x upside down. It's 1 over tan x, which is cot x, the cotangent of x. So we can say, keeping the negative sign there, it's negative cot x, and the 1 over sine x is cosec x. Which means that the derivative of cosec x is negative. We'll keep cosec x, cot x. So I usually write it down with the cosec x first for some reason. So it doesn't matter which way around it is, that's our derivative there. And lastly, the derivative of cot x, 1 over tan x. So that's for saying that cot x is cos x over sine x. It's tan x upside down or inverted. Cos over sine. So we're going to use the quotient rule again, just as we did for tan x in the beginning. So the quotient rule, u dash v minus uv dash over v squared, where u this time is cos x and v is sine x. So we've got a similar result to tan x, except it'll be the other way around. U dash is negative sine x, and v dash is cos x. So when we substitute this in, u dash v negative sine squared x minus, and what we got, u and v dash cos squared x all over the v squared, which is sine squared x. Now in the first one where we had the derivative of tan x, we had sine squared x plus cos squared x. We'd actually have the same arrangement here if we take out a common factor of -1, because that allows us to simplify that again. Sine squared x plus cos squared x is 1, so it's -1 over sine squared x. We know that 1 over sine x is cosec x, so that's going to be 1 over sine squared x is cosec squared x, and there's a negative, so we can write it as negative cosec squared x. That's the derivative, which means we can summarize that one by saying the derivative, d by dx, that's not very good, d by dx of cot x is negative cosec squared x. So that's all 4 standard derivatives of these new trig terms. I hope that that makes sense. Sorry if it's a bit quick, but the idea being that you can go back and try and work it out. If you have any questions, you can let me know. Okay, on you go.